Imagine a computer so powerful it could simulate molecules to cure diseases, crack codes that would take today's supercomputers millions of years, or help scientists understand the universe on a quantum level. That's not science fiction. That's quantum computing. But what does that actually mean? Today we break it down. No jargon, no fluff, just a simple explanation of what quantum computing is, how it works, and why it matters. Let's get into it. 1. What's a traditional computer? To understand quantum computers, we first need to understand traditional ones. Your laptop, phone, and even NASA's computers all rely on bits. A bit can be a 0 or a 1. That's it. Every app, every game, every website, built on billions of zeros and ones. This is called binary computing. And it's how all modern technology works, until now. 2. What makes quantum different? Quantum computers use something called qubits. Unlike bits, qubits aren't limited to just 0 or 1. Thanks to quantum mechanics, a qubit can be in a superposition, a combination of 0 and 1 at the same time. It's like flipping a coin, and instead of just heads or tails, it's somehow both while in the air. And that's just the beginning. 3. Superposition and entanglement. Quantum computing is built on two strange but powerful principles. Superposition. Qubits can exist in multiple states simultaneously. That allows quantum computers to perform many calculations at once. Entanglement. When two qubits are entangled, changing one instantly affects the other, no matter how far apart they are. This creates an incredibly fast and powerful form of coordination between qubits. Together, these principles allow quantum computers to scale exponentially. With just 300 qubits, a quantum computer could perform more calculations at once than there are atoms in the universe. 4. Why is quantum computing important? Quantum computing isn't just about speed, it's about capability. Here's what quantum computers could revolutionize. Medicine. Simulating molecules to design new drugs faster and cheaper. Cybersecurity. Creating, and possibly breaking, next-generation encryption. Climate modeling. Analyzing weather and climate systems in real-time finance. Solving complex optimization problems in seconds. Logistics and AI training smarter models, optimizing traffic, even space missions. These are things classical computers struggle with, or simply can't do at all. 5. Are they real? What's the status today? Quantum computers do exist, but they're still in the early stages. Companies like Google, IBM, and startups like IonQ and Rigetti are building quantum machines that work, just not at scale yet. In 2019, Google claimed quantum supremacy when their quantum processor solved a problem in 200 seconds that would have taken a supercomputer 10,000 years. That was a milestone, but we're still a long way from using quantum computers in everyday life. Right now, they're experimental, expensive, and extremely sensitive to noise and error. Quantum computing isn't here to replace classical computers, but to solve problems we can't solve otherwise. It's a leap forward in our ability to simulate nature, optimize systems, and understand complex data. And while we are still in the early days, the possibilities are massive, and the breakthroughs could redefine everything from healthcare to cryptography. If you found this helpful, drop a like, subscribe, and let us know what part of quantum computing you'd like us to explore next. Because the future of computing isn't just faster, it's quantum.